Our next speakers are Lorne, Grieger, and Dana Burnett with Prairie Agricultural Machinery Institute. They have an ag engineering background, so they're going to be talking about those research they do with magical groundwise.
Thank you so much, Ashley. It's a pleasure to be here and talk to you some of the projects that we're working with currently with Manitoba Islands. Starting off with looking for the slide advance right there. In terms of our contact information, if you have any questions or if you'd like to email us, by all means, please reach out to us on our contact information. Both me and myself, engineers by background training and have farm backgrounds. That's part of what we bring to PAMI, is that combination of technical as well as the theoretical that we're talking about in terms of our programs that we do, how we look at the overall topic at hand and the others that we'll be discussing today. And just an important note of our organization, PAMI, we're a third-party independent, so we're not tied to any particular manufacturer or organization. That allows us to make sure that as we look at topics, subjects, that we look at it from a different angle of any interest or objectives of the healthcare asset. Happy to talk to you if that's a particular subject and some of the research work that we're partnering with Manitoba Crop Alliance. And in terms of where we fit into the spectrum, we do research work. It's on the applied side. So answering that question, if we're going to study something, so what does it matter? For one, make sure that we always keep that in mind. How do you implement anything that we learn into your operations here now, put that into practice here in coming years as part of the work that we do? We fit that bridge in between universities as well as organizations that we're already selling the products or farms themselves. Looking at how do we use this to implement that for our overall practice here as a whole. Really happy to partner with organizations such as Crop Alliance. We work with a lot of different commodities. There's some example here is Saskatchewan, Alberta. We're working to make sure that we look at topics that are kept at prairies, but also are more local touched in terms of the work that's being involved. How does local growing conditions, soil conditions, climatic effects, and implementation or particular subject, topography or tool, and as part of that process. And we look at it from viewers' priorities, where the shelter, those the areas here that we want to talk about. Particularly, you look at increasing your efficiency, increasing the bottom line, looking at your productivity as a whole, and then some of the challenges that go with that. Moisture conditions, hence of the year we've had extremes, both dry as well as excess moisture, and the impact back in altitude. So if your yield in the springtime, and part of what we're looking at here today is trafficability or impact on that soil compaction, both at the surface layer as well as we get into the subsurface layers. To see the data that I've procured recently, one of our research projects, and then progressing through the season as we talk about header losses for sunflowers and rate dryer efficiency. But that's part of the topic here today, as Denisman talked in detail to some of the work that we got here most recently for projects starting off.
Excellent, thanks, Lorne. I figure we'll start this off. I'm a new face at PAMI. I've been with PAMI about a year and a half, and I've noticed that Lorne tends to know quite a few folks around today in the audience. But hi, I'm the new kid. I'm an ag engineer by training, but my PhD is in biomedical engineering, where I've gone back to the farm and looked at human factors engineering. So we mentioned at PAMI we're a practical team. We make sure that we have folks that are practical, and thankfully I'm one of the PhDs that does have that practical application, so we're able to share some analysis and some information with you folks on the research leading projects that we're doing. So this one, looking at the trafficability, the effect of low ground pressure traffic systems proceeding on soil compaction and cereal yields in heavy clay soils affected by extreme moisture conditions. So just a brief definition of what trafficability is. It's the soil's ability to support agriculture traffic, and how the soil behaves when something has driven over top of it. We're looking at compaction. We're looking at how those soil properties may change. And the reason why this is important is because the seeding window in Manitoba is very narrow, and there is pressure to start seeding. It's almost a race because that window is so narrow. So you either start early when your conditions might be too wet, affecting how that soil behaves under that compaction, or you wait and risk further delays, which may impact emergence, yield, and all the other wonderful things that we're looking at. And another thing to consider when you're looking at soil compaction is our equipment is getting larger, both in size and in weight, and the bigger something is, the more mass it's forcing onto the soil, and the more likelihood there could be for compaction in those tractor-tired areas. So this research project rather, is looking at how do the available low ground pressure systems enable operation in higher moisture conditions, and that impact on soil compaction and sustainable yield. So we're driving a very large vehicle over the field. What does this mean with emergence and yield? How does this affect our crops? How does this affect the dollars that we're putting into our pocketbook at the end of the day? So this is a multi-year, multi-site project. We're comparing 2 ground pressure traffic systems. So we're looking at tires and we're looking at tracks. And we're assessing the effect of the axle weight. So we're also looking at 2 sizes. We have a 10-ton load and a 20-ton load in different soil moisture conditions. So in 2024, we've had a successful field program on a single site where we have both emergence and yield data to share with you folks. And our plan for future work, 2025, and that should be 2026, is to do data collection on more than 2 sites. I'm a bit of a data nerd. The more numbers you can get to build your model, the better your model is going to be. So we would like to do the same thing in a few different places and see if the phenomena holds. So this is our field location. This year was a single location near Rapid City, and this is just a little bit closer look at that northwest quarter. We seeded soybeans on it. May 11th, well, we didn't seed it. We worked with a producer partner to do the seeding for us. And you can, when you get into that image there on the far left, or the far right, sorry, my left, your right, you can see visually from the satellite image where those compaction tracks are. So this is a field site that has many years of very precise trafficking, very precise decisions on where those wheels are touching the soil. So this site has allowed us to collect data. Although the data is reflective of one growing season, the soil behavior is reflective of many years of careful decisions. So we applied our compaction post-seeding and perpendicular to the controlled traffic tram. So that controlled traffic tram, those are the lines that were visible from that satellite image. So the controlled direction. So we went opposite, 90 degrees from it, perpendicular to it. And we drove over with 4 different times. We used a cart with 36-inch tracks with both 10-ton and 20-ton mass. And then a cart with high flotation tires, both with a 10-ton and 20-ton mass. And that little diagram on the bottom is just showing our different sites where we're collecting data and how our disturbance, essentially, with the compaction is going against where this really awesome site to work with, where those years of compaction decisions have been made. So this is a visual from the field, looking at the 10-ton load with tracks and tires. Now these photos are taken immediately after that compaction was applied. And you can maybe see a little bit of a difference when you check out on the horizon between the tracks and the tires. But as a first glance, immediately after seeding and immediately after application, there's very little visual difference. Similar story with the 20-ton weight. Again, you get close to the horizon, you can kind of see where that track trail was and where that tire trail was, probably more so with the tires than the tracks. But at time immediately following seeding, there's visual disturbance, but between the two different types, there's very little observable difference. Now, looking at the soil physical data, this plot is cool. We have essentially porosity. So these water content measurements were taken when the soil was fully saturated. So this is essentially a soil porosity measurement. And you can see the difference between the control down in the bottom there in red and all of the tracked situations, showing that your tracked, it has a tendency to hold more volumetric water content, which is kind of cool. Next up, this is some soil physical data. So this is penetrometer data. So what this instrument does is it's a probe that we stick in the soil to measure the compaction, or measure how much pressure or how much force resistance is in that soil. And something that's really neat out of this plot, it's difficult to tell, but if you look at, there's this red line that seems to be separate from the rest at the very top of the plot. That's our control. And that's up to about a depth of about 10 centimeters depth, where there's a distinct difference between where there were no tracks and where there were tracks. And again, the 4 situations where we've applied pressure to the soil, they all kind of cluster together. There's no obvious distinction between them all at this, but there is a distinct difference between our control and the pressure applications. So emergence data, this was taken at about day 55 of emergence. Again, we're seeding soybeans on here. The plot on the right there, now this is flipped around. We've got control on the far right, and each of those trials as a bar. Now, again, similar story. Very little differences in emergence between the 4 applied compaction treatments, but very significant. In fact, about 10% or an additional two plants per square foot on the non-compacted region. So again, these are phenomena that we see qualitatively. So you go out to the field and you're like, yes, I'm observing this. But now with this research, we're putting that observable phenomena to numbers. So what you're seeing is in fact what's going on based on the data that we've collected. So this is just another visual of emergence. Again, you can see where those applied tracks were. I'm not certain which vehicle it was, but at this point and based on our emergence data previous, it really doesn't matter. When there's tracks, the emergence is reduced. So now, this year, this data, what makes this data important is that we have both seeding and harvest yield. And again, this picture during harvest, so that's our little plot combine there and on the far left side, and then our grain cart. You can visually see where these tracks have been deliberately placed. Again, making this field a great candidate for this study. But again, the plot on the far right there, same thing. Reduced yield under compaction treatments with higher yield on the control where there's no compaction. So the future work, an N of 1 does not a study make. We need more numbers. So we're going to go to a few more sites this coming year to get some more data. But as I'd mentioned before, there's very few differences in the penetration resistance, that force that it takes to get something into the soil between any compaction treatment. Both emergence and harvest yield was lower for tracks compared to tires, but that was not a significant difference. There was an observable difference, but that wasn't significant. And again, the axle weight, whether it be 10 ton or 20 ton, in this study had very little effect on the agronomic outcomes when it came to this trafficability study. So again, take-home message, doesn't matter what you're driving on or what you're driving with or what kind of what the type of tire or track that is hitting the soil, it will have an effect on emergence or yield based on this single field that we looked at. So I'm going to go very briefly over this multi-year study looking at grain drying efficiency. This is mostly an update on the work that we've performed on this project this year. We're in year 2 or 3, I think year 2 of this project. And really it's just getting more samples, getting more data. So again, some background. Grain drying is an essential practice. We need that grain at a certain level of dryness to ensure safe storage. Increasing efficiency will likely increase the black in your checkbook, right? So we're looking at increasing the efficiency of these dryers, but in order to find out if you're doing any better, you need a baseline. So a lot of the data that we're collecting in this grain dryer study is looking at the baseline. What is the input? What is the effect? And if we know what that input is, then we can manipulate the effect. So phase 1 was just a review of what's out there, what's been done, how do we develop our methods. This has been complete. Phase 2, we're looking at the baseline energy consumption of grain dryers at a few different operations. And then once we have our sample and our signal separated from our noise in our data, then we'll start to investigate the practices in these sites that seem to have higher efficiency dryers. So this year we have data from 2 additional sites. They're both the same style of batch dryer. One's propane fueled and one's natural gas fueled. And our primary focus again is on corn drying. And these are just two images of the drying unit. So very, very similar unit. Your source energy is just from 2 different sources really. We installed data loggers and sensors to look at air input temperature and humidity. And then we're also looking at the temperature air of the existing plenum. And then voltage, current, and watts, that's going to give us the amount of energy that's put into the system. So this is just an image of, say we show up at your farm and we want to monitor your grain dryer. This is kind of the instrumentation that we would put on it. Simple temperature probe in the middle, the odd item inside the control box, but really it's kind of a one and done day. And then we walk away and let you do your thing. So once we put it all together, we'll have sensor data with the weight of the input grain, the moisture of the input grain, moisture of the output, and the quantity of fuel that was used. And in the bottom right corner there, those are the plots that we're aiming for, showing input and output temperature, humidity changes. Now that's over two drying cycles. You can see how that humidity change really, or the energy consumption on there rather, is really apparent over 2 drying cycles. And then again, once we've got this data, once we've figured out peaks and valleys, we'll look at kind of which systems were perhaps more efficient and what those operators were doing. Again, if you don't know your baseline, how do you know if you're doing any better? So. And going forward, we're going to add 2 different style sites for 2025 season, and then plan to change the drying sites with the intent to help operators improve their baseline efficiency. So with that, I'll pass it over to Lorne, and he can talk about our 3rd project.
Thanks, Dina. Pleasure to talk a little bit about the work that we're doing on wet header losses with sunflowers. And thank you to our partners, Manitoba Crop Alliance and AgriTruth Research as well as part of the overall process for looking after this. And what do we want to do? Well, we want to do a study in understanding where is the losses coming from and identify it's a large part of that process, looking at the header. And you look at the potential impact that has in terms of 1 or 2% loss. That's a significant impact in terms of yield block that goes into pocketbook end of the year. And preventing losses that has a chance to expand into larger acres. So that's what we want to try and quantify starting off. Get a bench line, get a baseline to look at what the losses are currently being experienced with producers here in Manitoba. And one thing that we found that there isn't a lot of information out there, and that's part of where the study started from, is getting that baseline to start with, understanding where we are in terms of the field objectives of causes of losses, as well as quantifying the effect of ground speed and the variables that go into a combine setup at each point in time. So, and then observing the factors that go with it as well as part of that too. When we looked at we had two different types and looking at the way to manage it. One of the things we did was initially taking the losses directly behind the header. So we used loss pans in row. We had them laid down, then we covered them up, and that was the first chance we had to look at, okay, what's your individual seed losses right at the head itself? We weren't going to worry about the combine losses coming off the separation cleaning system. It's purely looking at the header losses themselves and putting that into a number that we can understand for moving forward with different types of headers and the variables that go with that as part of the process. One thing that we did find is to start looking at losses. Yeah, we collected seeds in our loss pans. Definitely noticed that there's some seeds. When you start looking back through your row, though, you put a loss pan down and you cover it up and look at your losses, and then you start walking back and you realize the number of heads that can be left in rows. That's an area that we started to focus on, and a way to quantify that quickly and easily and estimate the number of seeds that came with the head losses that were coming off the different comments that we're working with. One of the things we did was put this together in making this easy instead of hand counting every single seed. That is an option, but the ability to go and quantify that based on estimation on diameter and allowing someone to essentially then at some point take a picture and quantify the number of seeds that are in a particular head and using that as an estimation for losses for a particular setup, whether it be for ground speed, header configuration, and so on. And that was one of the outcomes that we had right now, is looking at the number of seeds based on diameter. So it gives you that quantification right away. If you see number of head, quick measurement, it gives you at least a ballpark number to start with for your overall losses by lost seeds relative to seed head size as part of that process. We had two different sites this first year, and this is really developing a methodology to help us with year 2 and 3 as part of that process. In this particular site, it was a custom adapted John Deere header, so they added their own different dividers as well as fingers to add to that. And looking at the different types of conditions, 4 mile an hour was about that number that they used for their ground speed as part of the harvesting process. One thing you notice is that without having the back across, that you were losing some heads across the back end. So first thing to do something simple, minimize the number of heads going over the top and the back of the header, and adding a screen to help that process. As you start looking at seed counts and estimation in terms of numbers that go with it and overall size of the process, significant trash, and that's something that we find too, just being able to get a pan down and understand how many losses are coming from the header. So we start focusing on the heads, and that's where the majority of the seeds were as part of that process. Second field that we're in had a Sunmaster header, and they're going between 4 to 5 miles per hour, and they had a full screen across the back. So when you start looking at losses from full heads, a lot less as a result of just some simple modification or simple additions to the header, having the screen across the back end, and making sure that those seed heads were minimized for loss as a whole. We started looking at what's next. Well, plan for year 2 is taking those losses and converting that into, can you take a calculation and add that into a head loss estimation for number of seeds per head. So you can quickly and easily, as a grower, see, okay, this is the size of head. You can do a quick calculation, much like we have for soybeans, where four beans per square foot, that's a bushel breaker loss. Same kind of process, could quickly identify, add that into the things to check as part of field estimation program. So we're looking to continue working on this and taking the next step in collaboration with Manitoba Crop Alliance and developing a process for quantification and as part of a larger field program here this coming year. So those are the 3 projects that we have lined up, and happy to answer questions on any or all of the work that we've done to date, and look for your feedback on that. So I think Ashley's got a microphone. Stop.
Are there any questions for either Lorne or Dina?
There's got to be at least one question out there. Tough question. Okay. And this is where I'll pass it over to Dina now.
This is for her on the compaction issues. Did you find, or were you planning to test if there's any compaction issues with a pull between cart or a pull behind cart, just in the tractor tracks itself?
Yeah, that's an excellent question. That's one thing that we started looking at. How do you configure a full size or field scale test program so that you can maximize information and try and answer as many of those configuration questions? But yeah, that was something that we looked at. How do you replicate a tow between cart versus a unit that's coming behind it? No, this isn't exact. I love to have 3 different machines with different configurations lined up in the field at the same time. The reality is that isn't something that we can manage easily and quickly. So this is the next best thing in terms of getting that same kind of a track going into a field pull seating. So using essentially a grain cart to replicate the air cart for seating application.
Any other questions? Okay, with that, I will thank Lorne and Dina for sharing all of those interesting research results with us today. In lieu of speaker gifts, AgDays is giving a donation to the Manitoba Farmer Wellness Program. And so please join me in thanking Lorne and Dina.